In this video we're going to look at 19 through 22. The first one is to graph this function, which is a parabola. So let's find the x-intercepts. We know x-intercepts are when y equals 0. So to approach this, we can factor this expression. This is a factoring problem where we have to take out the GCF. So 2x is common, and then we're left with x minus 2. So our x-intercepts are when 2x equals 0 and when x minus 2 equals 0. So this equation gives us x equals 0, and this equation gives us x equals 2. My y-intercept, well, I can see here that the y-intercept is also at 0. When I plug x equals 0 into these values here, my y is going to end up being 0 as well. The vertex of the parabola we can find either using the vertex formula, negative b over 2a, or since I already know my roots are at 0 and 2, I know that my line of symmetry must be the average of those, or at positive 1. So the line of symmetry is at 1. So if x equals 1 for the vertex, it has to be along this line, I can plug 1 back into the original equation to find the y value. So 2 times 1 squared minus 4 times 1. 2 minus 4 is negative 2. So my vertex is right here. So I can sketch this parabola. Graphing form, y equals a, which is 2, x minus h squared plus k. Now in number 20, we're graphing the function g of x equals 6. So 1, 2, 3, 4, 5, 6. This is a line. This is g of x. This original function we graphed, the parabola, was f of x. At what points does f of x equal g of x? So depending on how accurate this parabola is sketched, you may or may not be able to use the sketch to figure it out. However, you can set the functions equal. So if g of x equals f of x, that means 6 must be equal to 2x squared minus 4x. We need to solve this equation by subtracting 6 from both sides, so 2x squared minus 4x minus 6. If I divide everything by 2, that would give us x squared minus 2x minus 3, which factors out to x minus 3 times x plus 1. So I can see here that x would be equal to 3, or x would be equal to negative 1. Looking at our graph, we can see whether or not that makes sense. So at positive 3, this graph should be hitting this point. Mine is a little bit off. And then at negative 1, again, this graph should be hitting this line. Graph the function here. At what point do those two intersect? So my vertex is at 1, negative 2. And the parabola opens down. Oops, not there. So it should be at positive 1, negative 2, right here, and then opening down. Where do those graphs intersect? F of x and h of x. So if this is h of x and this parabola was f of x, you can see that the only point they intersect is right at that vertex, at 1, negative 2. So consider the statement, the value of x when f of x is at its minimum is less than the value of x when h of x is at its maximum. Is this statement true or false? So the value of x when f of x is at its minimum, so this graph right here, when it's at its minimum, x equals 1, is less than the value of x when h of x is at its maximum. Well, when you look at this graph, h of x is at its maximum also when x equals 1. So this is a false statement because it's not less than, it's actually equal to.